This is the most difficult geometry problem from this year's AMC10 exam. It is problem 23. Now here we have isosceles trapezoid ABCD. The sides AD and BC are parallel, and BC is smaller. There's a P point inside such that PA equal 1, PB equal 2, PC equal 3, PD equal 4. So what is the ratio of BC and AD? Of course, no diagram is provided, but you probably want to draw one. Here, isosceles, meaning if you have vertical line here, this is going to be congruent triangle because it's parallel, right? So what you get is these two triangles, ABE and DCF, is going to be congruent, so AE would equal to DF. So assume the length is A and B, right? So here AD would be A plus 2B because this is symmetrical here, right? So this is what we get. Now the key in solving this geometry problem, however, it is analytical geometry. We're going to apply this into a coordinate system, right? So let's do that because remember we have distance, this special relation, those distance, from P to A, B, C, D, right? So that's probably the reason why you should think of analytic geometry, where we're going to put this figure into some sort of coordinate system, right? So let's do that. Now you can set either the point O, the origin at A, or in the symmetrical, in the center. I think you'll reach the same conclusion. Okay, the essence of it, of these two approaches are the same. Okay, you can try it out. But here we're going to choose the origin coincide with A. Okay, now what's the coordinate here? A, B, C, D. From the earlier conclusion, we know that this is going to be the coordinates here, right? So with that setup, we can now look at the original condition, right? For the point P inside, the distance will be 1, 2, 3, 4. Now we're going to assume the coordinate of P is going to be xy, right? So now apply the distance formula, PA, PB, PC, PD, right? So this is going to be what we have. Now notice, however, when you stare at these four equations, you notice that y minus h is common. If you do the difference, they will vanish. So let's do that. 4 and 1 share y squared. If you subtract, what do you get? You get this. 16 minus 1 is 15. Here is something squared minus x squared. Now similarly, 3 minus 2, you get this. All right? So let's look at these two equations closely. You know that the formula a squared minus b squared is equal to a minus b times a plus b. Let's do that. So this term, the difference, x would cancel. It's going to be negative a plus 2b. And when you add them together, it's going to 2x. Okay, so we apply the formula here. You get this. Now, similarly, there's a big typo here. This should be minus. Sorry about that. This should be minus sign. So, and you'll get that. Okay, notice this is a typo. Sorry. Okay, pay attention to that. Now here, the two highlighted equations have a common term. This is a common term. Okay, we can cancel the term if you do the ratio. Let's do that. So what is A? What is A plus 2B? Earlier we said this length is A, so which means it's BC. What is A plus 2B? That's the base AD. The D's coordinate is A plus 2B, right? So in other words, the ratio we're looking for is 1/3. Okay. Again, this should be a minus sign. Okay. So the answer to the question is actually B is the right answer. So the key in solving this problem is analytic geometry. All right. So hope you enjoyed the video. Please like and share.